Hello everyone, welcome to our lecture 5. In lecture 5, we will discuss about inheritance. We have already discussed it in our first class. Inheritance is properties of or a special feature of object-oriented programming. So in today's class, we will see that how to implement inheritance and the types of inheritance and so on. So I am your course teacher Supriya Sarkar. Let's see what is inheritance. If we want to recall our memory, inheritance is when the child class inherits properties of parent class is called inheritance. That means in real case scenario, you inherit properties of your parents, whether it is any materials or any other properties, but also we inherits our genetic properties from our parents. So parents class is called base class, and child class is called derived class. There are many advantage of using inheritance in object-oriented programming. The two main advantage is inheritance increases code reusability. That means if you write a code, you can use that code multiple times or how many times you want. Uh, these properties, that means inheritance increases the readability of your code. So let's see how it do that. So first we will try to create the properties, that means the properties of inheritance. So we will try to create class and its subclass, and we will see how they relate using inheritance. Now, first, in lecture 2, we discussed how to create a class. Uh, so here we create a class called parents. Parents is a class, and inside parent we just write a method which is function one, fun one, and self is our default parameter. And inside function one, I write. I just want to print that just I am inside the parent class. So the task of this function fun one is printing this line. Now I am inside the parent class. So again, I write another class which is called child class. Uh, I just put the name here, child class, but it is not necessary that it is a child class unless I write the parent's name of this child. If I write another parameter here, or parameter of this class, that means it is inheriting this class. It is inheriting this class. It is not necessary that it should be named that it is a child class. The class name may be anything. But when I write here a parameter which is the parent name of this class, now it is called a child class. So here child class is inheriting a class which is called parent. So here parent is its inheriting class. So inside this child class, I write another function which is fun2, and self is our default argument or default parameter. And inside this fun2, I printed a line. Now I am inside the child class, so that I can understand when I am inside the parent class and when I am inside the child class. So now I am creating a object ob. Ob is our object, and I created that object for this child class. How I create this? We already know that how to create or declare a object, new object. Here I mentioned child class. So object equal to child class, that means I created this object under this child class, not this parent class. Remember that, not this parent class, only inside that child class. So in the next line, I just want to call a function which is fun1, but fun1 is not belong to that child class. Here you see fun2 is belong to child class. Method fun2, not fun1. But I am here calling the fun1 by using this child class object. Ob is child class object, but I am calling fun1. That means parents class function or parent class method. I am calling parent class method through child class object. How it can be possible? It can be possible because this child class inheriting all the properties of that parent class. So uh, um, now I can access this fun class using this child class object. You see the result. The result is showing that I am inside the parent class. That means this object successfully access this fun1 method, because the child class is inheriting the properties of parent class. So if I want to access its own class method, ob.fun2, fun2 is the method of child class. So obviously it can access it. So now I am inside the child class. So child class can be easily accessible. Also the parent class is also accessible. So this is the properties of inheritance. This is called a simple inheritance. We will see the other types of inheritance in later slide. Now, as a child class can inherit all the properties of its parent class uh, along with its own properties. So, how to create is how to extend its own properties along with its parent class. So it is called override of parent class. So a child class can override its parent class using this init function. So let's see, init function always initialize object. So we know that in our previous classes, from our previous classes. So let's create a parent class and its properties or its attributes of attributes of its objects. So here I just write a init class, and self is our default object, and here name and salary are two attributes of created object. We will create object later. So here just this is a normal procedure. We already know that how they works. So here the new thing is I just print a line. Now I am inside the parent class, so that I can understand when I am inside the parent class and when I am inside the child class. So the next thing is, here I print the name and salary. Here I want to print the name and salary what is inside the parent class. The another class is child class. Here I write the its parent's name, so that we can understand that it is inheriting. If we do not write this, it will not inherit the properties of parent class. So next I declare another method, init method, and here I extend the properties. There was two properties, name is salary and name and salary. There are two attributes here, and in the child class it has three attributes along with rank. Then here I call the parent class init function, init method. So here I write parent dot the method name init underscore underscore init underscore underscore. Then their declaration self name and salary. uh, this is we should not write the whole code inside the parent class, inside the init method of parent class. We do not need to write the whole code. That means it increases the code reusability. So I just write the declaration of the new attribute, that is rank. Rank is our new attribute inside the child class. So I write that self dot rank equals to rank. Then I just want to print that I am inside the child class, so that I can understand when I am printing the child class materials, and when I am printing the parent class materials. So here I want to see the name, salary, and rank of this child class. So then I create an employee1 under the child class, not the parent class, under the child class, and pass three attribute value, Shahryar, comma 20 comma accountant. So why Shahriar? Because the first attribute of child class was name, the second was the salary, and the rank was a string. So accountant is the rank. So now I want to show what is the output. uh, if I try to show, if I try to see the output, the first thing will show that now I am inside parent class. Why? This child class, inside the child class, when I call this child class through the employee, so inside the child class, I just called the parent class. So it moved to the parent class and find that the first print line, now I am inside parent class. So this now I am inside parent class is the first line that will be printed. Then it will print self.name and self.salary. What is the self.name? The name is Shahriar. And what is the salary? Salary is 20. So salary is 20. And then it go back to the child class, and it will find that there is another print. Now I am inside the child class. So the next line is now I am inside the child class. Then the print option is self dot name, self dot salary, self dot rank. So self dot name is Shahriar, self dot salary is 20, and self dot rank is accountant. So when it is printing the attribute value of parent class, it is showing two attribute, because the parent class has two attribute. And when it is printing the attribute of child class objects, it has three attribute value. So it is printing three values. That means whatever your parent have, you have more than that, or you have equal to the parent's properties. So it is called override of parent class. Now come to the inheritance, types of inheritance. There are multiple types of inheritance. We will discuss one by one. First come to the single inheritance. We have already seen what is single inheritance in the first in the very first slide of our today's lecture. So I am providing another example here. It is when we will call it is a single inheritance when there are one parents and one class. This is very simple. One parent and it has one class, one child class. So here I created one parent class, and a parent class has a function one, which will print a simple line. The parent class is inherited. And I created another child class and passed the name of its parent class. Then I created another function fun2, and the fun2 will print a line, the child class is inheriting. So when I create an object now, single is the object under the child class. I created the object under the child class, not the parent class. If I create an object in under the parent class, it cannot access the child class materials, because parent class cannot access child class, but child class can access parent class materials. So see, so I created an object under the child class, which is called single. So I call single dot fun2. Fun2 is the method of child class. So it can easily access the line. It can easily access the materials of fun2. That means the child is inheriting. The first line will be printing that the child class is inheriting. That means it is a result of fun2. Single dot fun2. Then the next line, single dot fun1. So it is accessing the property materials of parent class. So here the function of the task of fun1 is printing this line, the parent class is inherited. So here the second line is showing that the parent class is inheriting. This is the example of single inheritance. Next come to multiple inheritance. So when there are more than one parent class, so it is called multiple inheritance. That means you inherit the properties of your father and mother. You are one, but you can access all the things of your father and mother, not for one class, for multiple class. So it is called multiple inheritance. So here I put the class name relevant to the example. So class father, here I can see a function under the father class, which is called father class is inherited by child. And there are another class which is also a parent class called mother, which is then under this parent class, I write another function which is fun2, and its task is to print the line mother class is also inherited by child. And there is another child class, so there is only child class, child, and and inside this child I just pass two parent class. Unless I write two parent class, it will not be example of multiple inheritance. Unless I write any of the name, it will not be a example of any inheritance. So here father and mother both are the child's parents. Then under this class I write fun3, which is whose task is to print the line the child is inheriting. So let's see the output. This is you are the object. So you is the object, equal to child. You are declared, you object is declared under child class. And now fun3 is the child class method. So you dot fun3 means it will print this line the child class is inheriting, the child class is inheriting. And you also a child of a child of father. So you can also access f1 fun1. The next line the father is inherited by child, the next line will be father is inherited by child. And u dot fun2 means it is the method of mother, it can also access mother class. So it will print the mother class is also inherited by child. So that's all. Now come to the multi-level inheritance. So I just took a real life example of multi-level inheritance when a child class act as a parent class of another child class. So your father is your grandfather is a parent of your father, and your father is parent of you. So this is a multi-level inheritance. Here I declare a grandfather class, uh, a grandfather class, and then under this grandfather class I declare a method which will print this line the grandfather class is inherited by father. And there is another class father class, and father class can inherit grandfather. So here I write the name of grandfather. Here under this father class, here is a function fun2, which has a default argument. And then under this fun2 this line will be printed. And there are another class child which will inherit a father, not grandfather, only father. So not grandfather, remember that, not grandfather, only father. So there is another function whose task is to print the child is inheriting father class. So if the child can inherit the properties of father class, it can also inherit the properties of grandfather. How? A gradual level, through a gradual level. So you see, you the child, you object is the child under the child class object, under created under the child class. So u dot fun3 means it is accessing, u is accessing the properties of its own class, because fun3 is written under the child class. So it is accessing the its own materials. The child class is inheriting the father class. This is the first line, the child class is inheriting the father class. Then u dot fun1, that means this grandfather class, you directly is not accessing it, you directly cannot accessing the grandfather class, but it can access the father class. So inside the father class, as father class is for the father class can access the grandfather class, so you also can access the grandfather class. That means whatever your grandfather has, it comes to your father, and whatever your father has, it comes to you. That means you access your grandfather's materials through your father. So this is the example of multi-level inheritance. You see here, u dot fun1 can access this line the grandfather class is inherited by father. Here you see the grandfather class is inherited by father. Next, u.fun2, that means this father class. As you are a child of your father, so you can easily access the father class is also inherited by child. The father class is also inherited by child. So this is called multi-level inheritance. Now come to hierarchical inheritance. When multiple inheritance of the same parent class, when there are multiple inheritance of a same parent class, is called hierarchical inheritance. uh, Come to the real life experience, real life example. Your father has two children, whether it is brother or sister. Your father has two children. So this is the example of multiple hierarchical inheritance. How? This is the father class, and this is child 1 and child 2. There are two other class who inherit this father class. So inside this father class, as usual, I write fun1, and it will print this line: the father class is inherited by all children. And there are another subclass, children 1, which is a child of father. And under this, I write a function which is called sys, and there is a default parameter. And the sys function will print this line: the children 1 class is inheriting the father class. So if I can inherit we will see in the output that whether this class can access this father class. Obviously this class will access this father class, because here I write children 1, and inside the bracket I write the father class. um, I write the name of father class, parent class. So here another class which is called children 2, and it is also accessing the its parent class, father class. So here I write a function which is called bro, and there is a default argument, and its task is to print this line: the children 2 class is inheriting the father class. So now come to the output section. I created object sib1 under this child 1 class, and assign to another object which is under child 2. They are different because they are created under different class. So now I just want to access, I want to test whether these two objects can both access their parent class. Sib1.fun1, fun1 means it is under father class, their parent class. So sib1.fun1 will print the father class is inheriting all children. Here you see the father class is inheriting by all children. That means sib1.fun1 can be accessed. Now sib2.fun1, it can be also accessed, but they can also access themselves. That means sib1.sys can be also accessed. Then sib2 dot bro can be also accessed. But if they try to access sib1 dot bro, it cannot be accessed, because sib1 is created under child 1. So child 1 has only function sys, and child 2 has only function bro. So sys cannot access this bro function, and sib1 cannot access this bro function, and sib2 cannot access this sys function, because they cannot access themselves. Among them, they cannot access the materials of they can access their materials of their own, but not their other siblings. But they can access materials of their parent class. So now come to the hybrid inheritance. A class has more than one type of inheritance is involved with hybrid inheritance. So let's see. Come to the grandfather class again. Here, a grandfather class has a function fun1, and a line. It will print the function. The grandfather class is inherited by father and child. Uh, Another class, if father class directly inherits grandfather class, and there is a function, and it will print a line as usual. There is another class, grandmother class, and there is another function fun3. It will print a line also. And there is another child class which inherit father and grandmother. father and grandmother, sorry, grandfather and grandmother. So that means this first class and second class. And the child class will also have a function fun4, and it will print another line. But the thing is, the child can access simultaneously the materials of the properties of grandfather and grandmother, so if I write uh, the but the father is only access grandfather, but the child can both the child can access both grandfather and grandmother. So the thing is, if I write that child can access grandfather and father, it will not a consistent method, because uh, child easily can if a child can access their grandfather, he do not have any need to access his father, because it is not any follow any hierarchical level or any multi level, because if it can access his grandfather, obviously it has access his father. So it is not a consistent way. So if a child access grandfather and grandmother, so it is enough. So it should yeah, uh, so it is a example of hybrid inheritance, when there is multiple when there is a example of multiple inheritance. It is it is an example of multi-level inheritance and multiple inheritance, when the example contains different type of inheritance, then it is called hybrid inheritance. This example contain uh, both multiple inheritance, and also it contains multi-level inheritance. So this is example of hybrid inheritance. So let's come to the example section, output section. It is very interesting. You in output section, u is a object, and u is object under child class. So u dot fun3 is the fun3 is a function of grandmother. So u easily can access grandmother, because grandmother is one of its parents, so there is no problem. U dot fun1 is grandfather, function of a grandfather. So it can also access that, because grandfather and grandmother is their its parents class. U dot fun2. So what is the problem here? Fun2 is a function of grandfather, sorry, father, only father. So father cannot be accessed by child, because there is no name of father. So here is only grandfather and grandmother. So u dot fun2 will create a error. Let's see the output. You see here, the grandmother is inherited by child. That means it produced by u dot fun3. uh, then u dot fun1 will create the grandfather class is inherited by father and child, father comma child. So it is also okay. Now u dot fun2 will create a error, because fun2 means it is under father, but you are trying to access, but father is not your parent, so you cannot access it. So it will create an attribute error. Child object has no attribute fun2. It is a error. So how it should be? If I create if I just modify the previous previous calling, u equals to children means u is an object created under children, and your father is a object created under class, created under father class. So u dot fun3 is okay, because fun3 is your method under your class. U dot fun1 is your grandfather's function, so it is also okay. Your father dot fun2 is okay now, because fun2 is a function of father class. So your father is created under father class, and it is also trying to access its own class. So father dot fun2 is okay now. Now this line, there is no error. The last line, it is creating the last line, father underscore father dot your father under dot fun2 will create the last line. The father class is inherits the grandfather class. Now it's okay. So that means the object is created under which class will print its class, its materials, and also prints its parents class materials, not the other class. So there is another thing, super function. Super function is used when we try to call our parents class directly. So the super class is used when we are trying to call the parent class directly without using its name. So here I created a parent class, and here I created another child class under this parent, which will inherit this parent class. And inside this parent class, sorry, child class, here I create another function, fun2, and I create super keyword. This is a keyword, super. So super dot fun1. Fun1 is a method of parent, its parent class, this child class parent class. So fun1 is the method of parent class. So it is directly called by super keyword, and then under this fun2, that means the function of child class, another line will be printed. The child class is calling the parent class. So let's see the output. U is the created object under this child class, and u dot fun2 is calling the function of its own class, child class. So now let's see what happened. It printed the first line. The parent class is calling directly. Okay, when u dot fun2 is called, then the control move to this child class, and inside this child class we got a fun2 method. Inside this fun2 method we got super dot fun1, so it will move to the fun1 method. So here is a fun1, and inside the fun1 there is a line, the parent class is directly, the parent class is called directly. So this is the first output, the parent class is called directly. Then it come to the previous point, previous address. The next line is print, the child class is calling the parent class. So this is the next line, it will be printed, the child class is calling the parent class. So this is how we can call directly a parent class of a child class inside the child class. So that's all for today's class. If you have any query about this lecture, you can ask me in the live class. So see you in the live session.